So, good afternoon, I'm Abhijeet. You can call me Abhi, saving you a token each. And so I'm super curious, famous for going into rabbit holes, and also famous for creating automation scripts where it is not needed. So, before we start, I would just like to thank you for your time to come to this workshop, and I would like to have you a valuable thing to take away from it as best as to my capabilities. So, after 3 days of context overload, I would like to keep the workshop simple so that you have to do a couple of clicks and take away concepts as a thought experiment which might help you in the projects that you are doing right now. So, I think it's this one. Yeah, so the agenda for today's workshop is just to understand how to reimagine retrieval. So, I would not be talking about RAG because I believe we have heard that in the workshop more than 50 times already. So, today it's all about embedding retrieval and agentic retrieval. And embedding retrieval is not RAG. I would explain soon how that is different. And we'll only focus on two areas: how to improve retrieval using just focusing on embedding models itself, not the RAG pipeline or retrieval from vector databases, and how to effectively use the concepts that we learn from fine-tuning embedding models to apply it to multi-agentic workflows, and how we can use that to effectively reduce the complexity and hallucinations from multi-agentic workflows. So before we start, the open source software that we are going to use today is called Transformer Lab, and I am not officially affiliated with them, but I have contributed to the open source software by creating certain plugins for them, and it's a very cool software, and there is no sign up required. You can just download it and get started. So on the left would be the link to go to the download page directly, and on the right is my OpenAI key. And before we get started, one important note is do not run bulk jobs using my OpenAI key because I would be broke. So that is the only important thing you have to remember. So before we get started, I'll just wait for 30 seconds or 1 minute just to confirm if you were able to download the tool and start it, and I'll just show how it looks. So if you scan the QR code, you would reach to a link which is this transformerlab.ai/doc/download, and the founders of this open source initiative are like Tony and Ali. They are serial entrepreneurs having more than 25 years of experience. They are really cool people to work with, and any of you can contribute to the open source project as well by creating cool plugins, which doesn't take honestly more than half an hour to do. So once you click on download, any Windows user here, please raise your hands. Okay, so ensure that your default distro for WSL is Ubuntu, and everything should work really well. So once you click on download, you will get image for Mac OS and an exe for Windows. You can just install it, and after you install it, you'll get something like this. So this is the tool that you see, and I'll just spend 2 minutes on the tool itself. What can you do with this tool beyond the workshop? So what you can effectively do using this particular tool is that you can fine-tune any models available in Hugging Face using very simple clicks. You can create pre-trained models yourself using the Nanotron plugin available inside this tool. You can also use accelerate plugins for multi-GPU training. You can also fine-tune embedding models, which we will do today together, and you would also create synthetic data sets for any use case that you have in mind. And one important feature is that it can be used also to run evals on any LLMs or embedding models that you have, and there is a complete package of evaluations like red teaming LLMs, finding bias, so everything is present in the tool. And the best part, it it runs in your laptop or your server. It's completely in your control, and you can change it however you want. So it's a complete open software. Yes.
So your image for Linux, I can directly put it onto Ubuntu within
Yep.
my Windows.
Yeah, that works. And there is a separate component for the front end, which is an Electron app, and the back end, which is a Python fast API. Alternatively, what you can also do is run the Electron app that you see on your laptop and run the fast API on any cloud provider as well. So you can have access to GPUs if you want to do LLM training. So a raise of hands, please, for everyone who have downloaded the tool. Cool. So the first step that I would like you to do is go to the plugin section. So there are some plugins which I have developed myself, and one of them is the embedding model trainer that you see. Before you install this, I would also like to say that in the last week's release, this plugin broke. So I would like you to manually edit 2 lines in the source code so that this plugin works, and this would be fixed in tomorrow's release. Like every Thursday they do a release, and unfortunately they didn't take care of my plugin. So so once it is installed, what I would like you to do is you can open VS Code and navigate to the folder called dot transformer lab, which is directly in your home, like just tilde symbol and slash dot transformer lab. For Windows, it might be in a different location, but for Mac users, you have dot transformer lab as the folder, and I can show you in the file system as well where it is. So you can go to, this is my home, and if you press command shift dot, you can see all the hidden folders, and this is the folder dot transformer lab. So by default everything gets installed there, and since we are using one of the plugin, what we'll do is we'll go to src and transformer lab plugins. Here is where all the plugins stay, and inside this folder you can ideally create any plugin that you want for yourself, so by using all the existing capabilities of the system. So what we'll be using today is the synthesizer docs plugin to generate data for fine-tuning embedding models, and inside this, like, there are just 2 changes that I would like you to make. For people who are not going to run the tool now but later, you can just skip this part. For people who are actively trying to run the tool right now, in main.py inside synthesizer docs, which is inside the plugins source transformer lab plugins, there is just a small change. So here a dot params would be missing in line 233. I would like you to add that, and in line 256 a dot params will be present. I would like you to remove that. So that is the only change that you have to make, and then everything works. So to repeat, line 233, add dot params after tflabgen. Sorry, yes.
Can you zoom in?
Oh, my bad. Yeah. Let me use both hands.
I couldn't find this folder. See?
Yes.
Sorry? Yes?
Should this repo just like appear in our files from downloading the?
Yeah. Let me just point out.
What's the second change again? Sorry.
Yeah, so the first change is this particular part, line 233, you just need to add dot params, and in line 256 you need to remove dot params. Yeah, it is inside main.py under synthesizer. Thank you, Abhi. Yeah, so
Sorry, I cannot see the folder name and all that. It's too far.
Okay.
The change will be on the
Find it, or so I'm just writing it down for a moment.
Did
you download the plugin?
Yes.
Oh, okay. So you can't find synthesis underscore docs.
It's called synthesis.
So the dot transformer lab would be present inside your home slash your name like that, and then just press command shift period to view hidden files.
Oh, command shift. Command shift at period.
Anyone facing issues? Yes. Okay.
And so in the interest of time, what we can do is tomorrow's release will fix this. So you can rewatch the recording and retry it tomorrow, because it would be fixed in the next release and you don't have to do it yourself. It would work right out of the bat. So let's proceed ahead.
Excuse me, just a question though.
Yes.
At a very high level, what your software allows us to do is for download transformer lab, if I already have on-prem models like Sven or Nama from Hugging Space, we have downloaded and deployed. So does this connect to those, or it has to connect to now for fine-tuning our on-prem model?
Yeah, so the question is, does it work with the local models that exist in your laptop? The answer is yes. You don't have to run it anywhere else.
Or in our office environment?
Yeah, in your office environment, in your personal cloud, anywhere.
Yeah. I know. It's read the application.
So just to repeat, the plugin is called Synthesizer Docs inside the folder, which is this one, Synthesizer Docs, and this is the one. That's okay. So what we can do is I can show you how things are generated, and later you can try it DIY. Let's move ahead with the session. So
Can you show the QR code again? Thank you very much.
So now I said that I won't talk about RAG, but excuse me for just 5 seconds. So these are few techniques that we have already discussed in the workshop, and Abhi here already has provided a lot of detail about how to improve RAG and how to deploy production grade RAG systems. But there is something that nobody talks about much while attempting RAG, is to fine-tuning embedding model. So that is what this workshop would be about. And to understand the reason why fine-tuning embedding model is necessary and how it can help you to improve your any problem statement for domain expert, like domain specific problems that you are solving. So let's focus a couple of minutes on why fine-tuning is necessary. So as we already have seen in previous talks that we had yesterday and the day before, that embedding space is basically representation of certain features that the words or sentences might exhibit. And now when I say that there are certain features, there are different embedding spaces. The first is word embeddings and the other type is sentence embeddings. So in word embeddings, the words are positioned as per their constructs or their behaviors that are learned. For example, the similar example that was given on yesterday's opening talk was comparing elephant, animals and fruits. So fruits would be grouped together and animals would be grouped together in a word embedding space. But what about sentence embedding? So when it comes to sentence embedding, it is very important that we understand what those behavior mean. So it cannot be just weight, height and color, because these are these can be identified by individual words and they exhibit this behavior, but these are not sentence, it doesn't determine a sentence explanation. So an interesting fact is that if you take a 100-dimensional vector space, there can be more than 10,000 approximately perpendicular relationships. What I mean by that is, if you take an angle of 90 degrees, you call that as perpendicular. But if you slightly adjust it from 89 to 91, give it a range of 2 degrees, you can have potentially 10,000 combinations of vectors that are exactly perpendicular to each other. What does that mean is that in the sentence embedding space, from a particular knowledge corpus, you can extract 10,000 different perpendicular relationships that you can align new sentences towards. So if there is a vector space that identifies an explanation of an abbreviation, for example, so GOAT means greatest of all times. So similar sentences exhibit abbreviations or expansions. So there could be a vector that is expansion and similar sentences could be grouped towards that. That is what I mean by relationships. So in sentence embedding space, you need to try to find such relationships that can group certain similar sentences towards the space, and while retrieving, it helps you to find closest or farthest sentences to any query that you might have. So giving you an example, assuming there is like a generic space and you're trying to convert that into a domain specific representation. So once you fine tune an embedding model, what you can potentially do is, for a financial use case, you can have representations of market cap, future trends and competitors, and if you provide, let's say, quarterly reports or annual reports for financial companies, there could be groupings of sentences that exhibit certain behaviors. And by understanding that, if you relate a query and try to retrieve a chunk, it could be one of those that was retrieved successfully. Similar to that, in a healthcare domain, what you can do is you can have confidentiality diseases about something about disease and something about new tech. So if you are analyzing a blog post or if you are trying to process millions of healthcare documents, you can potentially group chunks into, if they are talking about confidentiality or about a certain disease, how it was cured, or about certain tech improvements in the healthcare industry. So this is how fine-tuning embedding models can potentially help group certain sentences or certain chunks into relationship representations. So I want to spend some time on describing data sets that are usually used for fine-tuning embedding models, and they are really different to data sets to fine-tune LLM models or other models that you are familiar with. So when it comes to embedding models, there are around 11 to 12 types of data sets, but these are the primary 6 data sets that we see. So anchor positive is just a query chunk pair. So if I ask a question, what is the relevant chunk that potentially has answer to the question or is very similar to the question in terms of the relationship that I explained earlier. So anchor positive negative are a type of data set where you have the statement or the query along with a positive pairing and a negative pairs. So what chunk shouldn't be similar to the query and what chunk should be similar to the query. So that is the second type of data set. The third is best for distillation. So when you have a very good embedding model and you want to take certain features out of it and want to distill it down to your custom embedding model. So you use sentence A, sentence B and score representation for that. And for classes, it's a very unique use case. Why? Because understand how a human finds something in a book. So if I give you a book and I ask you, find the answer to this question, how does a human think? You won't start from the first page. You would quickly open something in the middle, or you'll quickly open the content, like the explanation, and go to the chapter directly and try to skim through the sections really fast and deeply read a particular paragraph. You won't read everything else. So when it comes to classes, imagine a large paper split into different sections like abstract, the background, like theoretical background about the paper and the technology, then certain implementation about how a proposal of what can be done, then the experiment section, and finally the conclusion or future trends. So imagine you create classes of class representations for each chunk, and you connect those classes to those chunks, and then you fine tune the embedding model. What happens in future is, if I ask what is the future of XYZ and a paper is about XYZ, it will not it will retrieve chunks only from the conclusion section automatically, because chunks from that section has been classified with type conclusion. So this gives an added benefit of retrieving relevant chunks based on the class type. So these are some data sets, and the most primarily used is the number 2, anchor positive and negative. To show you some examples in Hugging Face how these data sets look. So this is the positive and anchor type data set where you have a question and you have the right answer or chunk to it. Some other examples of similar data sets are query and answer, and these are the triplet data set, which is query, positive and negative. And we also have pair score, sentence A, sentence B, and score representation of the same data set. Yes.
For the positive, negative ones to be useful, should the negative be like still fairly closely related to the query, but just like not directly useful, or can it be like completely different topic?
It can be anything. It can be similar to the query but not useful. It can also be completely separate chunk. But what do you do with this data set is you tell the embedding model which sentences are, or you're just trying to change the embedding space into a way that will help you retrieve relevant chunks. So you're pushing away bad chunks and pulling in relative chunks to the respective query. And in future, once you perform retrieval, the positive chunks are more likely to be in the top K compared to the negative examples.
Does it tend to work better if you find like harder, like what humans maybe would consider to be harder to distinguish, and then it's more challenging, so you have a better separation? Is
Yeah.
there like some kind of guideline for that?
Yes, so while generating data sets, an easy way would be to first programmatically create data sets, do a first like few iterations of fine tuning initially, observe how the evaluation, how the evals are performing, and accordingly fine tune the data set further to make it like much richer and much more targeted towards your use case.
Kind of like an active.
Yeah. Yes.
And in your slide you mentioned data sets, right? So can we instead call them as data set types, because
Yes.
the data set would be specific to my industry and my
True. Yes. They are data set
So
types.
we do have to create them ourselves in our own specialized industry
Yes.
for
Yes.
fine tuning any existing model. So are these models having an inherent ability to have this kind of data set types? Because you listed some very specific data set types in your slides, right?
Yes, so you can use any dataset type to fine tune an embedding model. It's not very specific to a particular dataset type, but what would change is the loss function and what you can do, what do you want to do, how you want the embedding model to change.
My question was that these specific models, let's say from Nama or when they have preference for specific data set types.
Yep.
So they would have their own specific preference. That if you're creating a data set, create it primarily for this kind of data set types, because we are fine tuned better by.
Yeah. Yes.
If you're sort of like tuning your data set based on like ensuring that the tuning works better, how do you like keep that from overfitting?
Yeah, so it's a very tough challenge to understand like overfitting, because what you essentially do is there is an embedding like representation, and you introduce like new pairs for it to focus on, and initially it will more likely tend to overfit, because you would see the performance of the examples that you have provided. Similar performance would be like really good, but there might be some cases where previously well performing query responses might be affected. So it is more of a I would say hit and trial method initially, but once you understand which data type is helping you reach towards the solution that you need, then you can fine tune it further. So I think like I personally haven't found a definitive answer to stop the model from overfitting yet. So after the dataset types, there are a little introduction on loss functions and modifiers. So once you have selected a particular dataset type and a candidate embedding base model, the next part is for you to select the appropriate loss function, and I would come to the modifier after this, but the loss function essentially ensures that the query and anchor examples that you have provided, the embedding model tries to bring them closer to each other. So in the first case, multiple negatives ranking loss, the type of dataset would be query and chunks, and it would try to bring them close in the embedding space so that any similar retrieval would be enhanced going forward. The triplet loss is for the query, positive and negative examples. So then you can use triplet loss to pull the positive closer to the query and push the negative examples away from the query. So that is what these loss functions are doing. And what are loss modifiers? So there are three loss modifiers: Matryoshka loss, adaptive layer loss, and a combination of both. So a brief explanation of what they are doing basically is, when you also add Matryoshka loss modifier to a fine-tuning pipeline, what happens is it tries to also fine-tune the embedding model for a lower dimensional space. For example, if we take a candidate embedding model called BGE V1.5, it has 768 vector dimension. So what if you apply Matryoshka loss, what it does is it also trains it for 768 by 2, which becomes almost 384, and then further down to half of it, further down until 64 dimensions. So what happens is the fine-tuned embedding models would be able to perform well even in a lower dimension space, and it is more towards deployment optimization so that the size of the embedding model becomes smaller, but the ability of it to identify relationships stays the same. Similarly, in adaptive layer loss, what happens is it tries to imbibe the ability of the embedded model to perform even without even with trimming some of its layers. So imagine a model having multiple layers, and you can just strip off few layers and it would still perform well. So that is what adaptive layer loss would do. Now that is done for all the introduction. Now let's go to the tool itself and see how you can generate dataset and you can fine tune an embedding model in less than 30 minutes on your laptop. So the first step is to just go to the plugin store and install the embedding model trainer as well as the generate dataset from documents. So these are the two plugins that are required. So we would generate data from documents using this plugin, and we would use the embedding model trainer to train embedding model using the data. So the way we do it is we go to so we just reinstall the plugin once. Reinstall. So it installs the generate data from documents plugin, and so you can go to the just a minute, I think just restart it. So the first, in the foundation tab, you can select any like open source model. So for the sake of me able to run it in my laptop, I'll select a very small model, which is 1 billion 4-bit model, and I can click on run. It would just run an inference server on my laptop directly. And but I just want to generate dataset using this. So I'll just go to generate section, add a task, and I would select generate data from documents. So in generate data from documents, we have a generation model which we can select which one to use. So since I'm using OpenAI keys, I can use, let's say, any model that I want. And then you can select the chunk size, you can select max context per document. So let's say I want to have 10,000 rows of data set. I can create 10,000 here, and the max context length, max gold length per context. So let's say I just select 51 and I make it 1, and then I click on generate dataset for embedding model. Now you would see that there are 5 data types that it can generate, which is similar to what I was explaining earlier. So you can select which dataset type to generate. So if I select anchor positive, it would generate 10,000 pairs of questions and chunks from the documents that you have uploaded directly. And if I select anchor positive negative, it will use the sentence transformers mine hard negatives function to also mine 10,000 hard negative examples for your dataset. And then you just click on save generation task and then queue it. So once you queue it, the task completes and you can see your dataset like this. So in this case, what I did is I uploaded NVIDIA quarterly reports and I tried to extract financial Q anchor positive and negative pairs out of the financial report. And I have roughly 455 rows in this dataset. And this dataset can also be seen in the dataset section under generated dataset. So you have a dataset here already. Then you go to train and you create a new training job, which is embedding model trainer. You go to the dataset, select the dataset that you just created, which is the one that I was showing, and go to the plugin config and you can select what type of dataset you just uploaded, just for the trainer to know that okay, I'm seeing these kind of dataset type. So let's say I selected this because that is the dataset type, and I can select the right loss function. And I'll also share a link to all the information about the loss functions and how they can help you get to an optimal solution. But you can select loss function from here, and then loss modifier. So it's the one of the 3 that we just saw. I can select none as well because you don't necessarily need a loss modifier all the time. And then I just save and then again queue them. So what happens is, if you queue multiple jobs, it takes care of concurrent workers and everything automatically. You don't have to worry about it. And once it is done, you can see that there is a success, job completed successfully, and you can view the model locally stored in your laptop. So that is the embedding model that I created. So with the experiments I've done, what I was able to successfully obtain is that taking a base BGE 1.5 model, I was able to, the first column that you see is the evals that I did. So what I essentially did is I first generated query anchor negative data from NVIDIA and Apple quarterly reports. Then I fine-tuned 2 models, one with just query and anchor, one with query, anchor and negative pairs. So I generated 2 embedding models. Then I generated simple pickle files that contained chunk and their respective embedding generated from the new models inside a particular pickle file. It's like a JSON just pickle. And then I retrieved, I transformed different queries and I retrieved it from the same pickle files. So you can look at the improvement percentages just by fine-tuning an embedding model using query anchor pair and query anchor negative pair. And what you see is the final fine-tuned model was successful 83% of the time to retrieve the best chunk for any given query just once. In the top, like if you set k equal to 1 and try to retrieve a single chunk, it is right 83% of the time. And if you retrieve 5 chunks, there is 97% chance that the right chunk is in the top 5, and the MRR is 0.8897, which is very good in terms of RAG UIs. So the main takeaway that I want all of you to have is, even if you do not use Transformer Lab, it's all about fine-tuning embedding models. So once you fine-tune embedding model, the chunks that you continuously store in VectorDB, that itself becomes very, I would say, enriched, and all the chunks become very relevant to the query of your domain. So if you are from finance, if you are from healthcare, if you are from a retail sector or industrial sector, any document corpus that you have needs to be fine-tuned, an embedding model needs to be fine-tuned, and only then the RAG pipeline would start. So without trying to fine-tune an embedding model, going to a RAG pipeline increase a huge engineering overhead, and you have to do a lot of hits and trials, trying to do hybrid search, metadata, and all the complex efforts to make the system better. Yes.
Sorry, I have a dumb question.
Yeah.
Can you explain what positive and negative question that you mentioned previously?
Yes. Yeah. So I would like to give an example. Let's say there is a simple question: what are NVIDIA's future plans? Just a simple query, and I want to retrieve right chunk from a financial document. So there can be a chunk that tells the CEO is planning to buy a house next year, and that is the reason he's trying to sell offboard his shares and trying to do something. There is a chunk that describes the CEO's future plan, versus there is a chunk that describes NVIDIA is trying to grow GPU manufacturing centers, for example. So in both the cases, if you do without fine-tuned query retrieval, both semantically mean future of NVIDIA, because even from an embedding perspective, CEO is an important aspect of a company, and whatever the CEO does in future impacts the company. But that is a negative pair. What CEO is doing, it does not correspond to the question. So for you as a financial machine learning engineer, you might represent the chunk where CEO is doing something as a negative example, and where NVIDIA is doing something as a positive example. And what happens is, in future, those chunks will not be ranked higher or will not be retrieved anymore. So you improve context relevance by a huge margin, and this is what context relevance evals are. So, my bad. Yeah, all of these are context relevance. Yes.
I'm kind of curious about how big of a data set do you need to do this kind of training?
I've seen good improvements in just 1,000-row dataset, and just to give you an example, if you use any tool to retrieve chunks out of a document, a 60-page document will create a 500 chunk dataset with 512 chunk size. So I have experimented with both 256 and 512 chunk size, and I observed personally that 512 chunk size gives a better transformation to the embedding model itself, because it has enough information for positive and negative understanding.
And let's say you are dealing with a very large data set. How do you ensure that you basically, you cover, everything across the board, and basically you don't end up basically biasing?
Yeah, so that is a good question. So we need to also have maybe a supervised dataset creation, because just creating dataset automatically using LLMs and embedding models and fine-tuning embedding models is not a right approach. But this is just to show how easy it is to do it, so that there is no mental barrier to fine-tuning embedding models, because it just takes 15 minutes and it gives you a very huge improvement. So that is what I wanted to show in the workshop. And the concept behind why focusing on embedding models as the first step is the right gateway to any complex engineering implementation in future.
How
Yes.
does Transformer Lab kind of deal with the nitty gritty of like having to tune parameters and deal with the kind of low level issues when you try to fine tune?
Yes, so for the low level issues, the libraries are updated. They do a very good job in focusing and finding out the right libraries to change. But in terms of hyperparameter tuning, everything is on the user. They do not do anything. They just give you like a large form. You do it yourself. But there are default values that you can take advantage of if you are a beginner or intermediate. But it's just trying to give you a UI for script. I would say Transformer Lab is all that, so that you don't have to code yourself, but just click few things and queue the jobs and get improvements directly. Yes, you had.
I have a silly question. So I tried to upload my own data set of documents, which is like chunks that are stored in a CSV. And when I upload the CSV, I upload it as a markdown file. And I can't figure out how to make it upload as a CSV. Do you know? Have you ever experienced that?
No, I think you can directly upload. I haven't uploaded CSV yet, but I think in the data set you have to just so in the documents you can upload like PDFs, CSV.
Yeah, so let me
And-
upload the CSV. It just uploaded it as a markdown file, which makes me think that it probably doesn't have the structure in it anymore.
So did you try to create a new dataset from the datasets tab, or
No, it was just in the documents.
okay, so you can try from the datasets tab to create a new dataset and just select the name and whether it's a text or image type. And they also support like I think dataset from Hugging Face directly. So if you upload your dataset to Hugging Face, you can add the name here directly and click on download dataset. That is what I do, because I like to keep my datasets versioned on Hugging Face. So I just upload them to Hugging Face myself and then use the private dataset name here directly.
Thank you.
So now we move to the interesting part where I have a giveaway for all of you, which is like a custom development that I did for the last month, because I have been into embedding models since when Suhas asked me to add this feature in the tool. So I've been playing with it, and I have found a way to include that knowledge into agentic workflows that can help you improve the orchestrator worker agent workflow in a very optimized way. So now that we know how fine-tuning embedding models improves your retrieval, which means a relationship understanding of relating a large paragraph or sentence towards a behavior or class or a representation, similar to how humans understand when three people are speaking and I just join in between, I can understand what's going on. So we're trying to mimic that feature into multi-agentic workflow as well. So it turns out that for subquery enrichment and routines and FAQs and introducing those functionality into agentic systems, the class representations for semantic search improves the entire multi-agentic workflow by leaps and bounds. So which we will discuss now, and I'll let you also download a small script that I created, which might help you in any multi-agentic workflow that you are doing going forward. So just to discuss on what multi-agentic systems are like, because it's definitely worth a debate to understand whether multi-agentic workflows are super powerful or they are just amplified hallucination risk, where one agent would misrepresent something, give that to the next one, and it just extrapolates from there and exponentially does something wrong. And so just to give an example, if somebody asks when is the next billing cycle, and the agent automatically increased the subscription cost by $10,000. So that might happen when it hallucinates. So these are some highlighted issues that I have personally listened from people developing multi-agentic workflows, which is instruction prompt too large to contain all scenarios and guardrails. So this is the major problem that we have when we try to create a single agent or a multi-agent workflow, where you give it, these are all the tools these are all the guardrails. This is the entire history of what's going on, and if this is the condition, you have to do this, do not do this, and it's a very huge template prompt that people write, and it's necessary because you want the agent to perform in a very targeted way. The second is context is lost in tier 3++ worker agents. What I mean by that is, let's say there is an orchestrator agent and I am giving a task to a sub agent, and then the sub agent is calling a tool. So the query sits with me and I can transfer the entire query, dump it into a sub agent, but that is not what multi-agentic workflow is for. So when you translate tiers, then the entire context is lost because the thinking aspect stays with the orchestrator agent. It doesn't translate to all the worker agents or the tools. The third one is if you use reasoning models for orchestrator, which is ideal because it needs to think, you have too many tokens that is used in reasoning, plus dumping everything going forward increases the number of tokens you operate with, and in a multi-agentic workflow you can increase the token usage by 50x as well in some cases when it gets stuck in a loop and consistently there is back and forth between multiple agents. And finally is the hallucination of approval and function arguments. So if there is a function that is complex with multiple arguments, I have seen agents call the tool in a wrong way more often than in a very appropriate with proper functions. So some tools can inject SQL queries into your system. So if you're using such tools in a multi-agentic system, it becomes very important that you control the approval part of it as well as the functional behavior of it. So these are some problems, and I would show you how to resolve all these problems using the concepts that we just learned. So this is a customer support agent that I created last month for a client of mine, and I'll just briefly go through this and I'll send you an image later because I think it might not be legible in a phone camera. So what I'm trying to do is, so this is a customer support agent for a company that manages Amazon ad spend for different Amazon sellers. So there are few tasks that the agentic system needs to do. It needs to understand the email, it needs to understand the history of emails, what has happened, and it needs to take actions on each particular request or query given by the customer. So an email can be, hey, what's going on with my product XYZ, last month why didn't it perform, I want to also see how my other products are doing, and thank you for sending the report. So there are multiple queries in a single email, multiple statements made. So the conductor agent must understand all of the statements and act accordingly to each subquery that we have. So initially, I'll use the pointer, we have a skip processing agent, whether to even try to analyze the email or not. If it is thank you for the feedback, we don't need to respond to that. So it's generic emails are skipped. Then we have updating thread memory. So here when you see I have bold, I've written in bold embeddings. What does this mean is, earlier I mentioned about class representations of statements. So even emails represent certain classes. So you can use the fine-tuned embedding model to create embeddings of each email, and later this guy would get the thread memory and get historical emails using certain queries that the agent might have. So find an email where previously customer was frustrated and how I handled it. One of the example. So conductor agent can find such emails where historically it has managed well and a human had responded to something, and it can learn from it immediately during the call and understand, okay, this is how my bosses have been replying back and I need to reply back in the same way. So that is where the embedding models help. So there is a thread memory, then we load thread memory, what happened previously, so that we have enough context to respond. Then we give it to a subquery agent. It extracts all the subqueries from the email. So it's query expansion. It has, if there are multiple statements, every actionable statement or every responsible statement will be extracted, and that would be given to the conductor agent, where it would be responsible to take action on every subquery and respond to the email effectively. So the part that you see here that I've used a fine-tuned embedding model is the most important aspect where I'm enriching each subquery with an FAQ. So what I did there was, there is an FAQ store that the company has policies stored inside. So there would be, can I have a call at 9 p.m.? Then the answer would be, sorry, our working hours are between 9 a.m. to 5 a.m. and XYZ. So similar to that, there would be a very large FAQ store. So what I did was, I fine-tuned an embedding model with class representation, and I connected each FAQ to a type of customer question or behavior. Now what happens is, for each subquery, it extracts the relevant FAQ directly, and then the conductor agent can decide whether to directly reply to the subquery or to use the FAQ to do certain actions that it cannot do without that knowledge. So I'm enriching each subquery with the relevant FAQ using embeddings. And one cool trick that you can apply, I'll just show you in the next slide, is to have multiple questions pointing to the same answer, so that you're increasing the probability of extracting the right question for a relevant query and get the response from there. So the conductor workflow that you see has a billing agent, marketplace agent, drafting agent, and few tools that it uses to resolve each query and respond to every email like a human. So the emails that are generated from this workflow, you cannot think that they have been written by an AI agent. It would be very human, colloquial, and lazy. It would be done, noted, that's all. It won't be very excited with exclamatory dashes, bullet points, and paragraphs. So you control that using the drafting agent, and you can see get email policies. So this is also using the embedding model to get relevant email policies before responding. So the drafting agent would have the information, it would get the policy, how should I respond? And according to the policy, it will draft an email which is very human-like. And these two that the conductor agent is taking care of is getting routine from query, which is given a customer query, what routine should I follow? And this is where you reduce the template prompt by a huge amount. So you just imagine you give a prompt, always use get routine from query before doing anything. Just a single prompt to the conductor agent. Now by doing that, you can control the amount of context or amount of prompt that you give to the conductor agent, and after running this function, it can understand what to do next. So that is what is going on. Yes?
Can you explain all these steps that you put in are driven by a LLM, or it can be done through just a function like a script?
It can be done through a script as well, but this workflow, what it helps us with is to be creative or expressive or generative. So we can add as much as heuristics as possible, of course, but sometimes to get or to keep a system flexible and to continuously make the best use of LLMs, you can introduce agents there. Yes.
Yeah, you have two distinct boxes.
Yeah.
Right? So the first box is almost like runtime, right? As the mail is coming in from the customer.
Yep.
It's happening at runtime. Right?
Yes.
And what about the second box?
This is the expansion of the conductor agent, how it offboards tasks to these are the reportees of conductor agent.
Okay, it's a
So,
continuation.
yeah.
Actually.
So this is like the manager. So the executive gives a task to a team manager, and team manager would take care of the task and give it back to the
It's
executive.
a continuation of that.
Yep.
The other quick related to that is you said thread memory, right?
Yep.
So this concept is like it's going to load relevant stuff in memory and make decisions.
No, sorry. Thread memory is nothing related to GPU or the memory itself. It is just a summarized statements of what happened in the previous email threads for the customer.
Yeah, that's
So
what
you
I
can-
mean. It's
yeah.
in context or it's a memory of the same customer from previous communication.
Even previous communications, current thread, so it would give you the semantic understanding of the sentiment of the customer as well.
So it has to be loaded from an offline thing to the thread memory so it can make the
Yes, so it would, I was using JSON-L files just to store them locally, but you can choose SQL or any database that you want. Yeah. So now, just a brief overview of how I created the agent. Now what you are going to do today is, so this is just slide about how the FAQ enrichment works. So I have a question and answer. As you can see, can we get on a call or set up a meeting? The answer is our current tier is email based, which actually helps, keeps your monthly fee lower, XYZ. And sorry, my bad.
Sorry.
And the embedded enriched queries look like this. So question, answer, embedding, and this is just a JSON file. You don't need fancy vector databases or anything. Store them in the same folder, and you can retrieve the right query FAQ based on. So what I did is I transformed the question into multiple possible queries that the customer might provide, and the answer is same. So that is how you can enrich FAQs and also routines, which we are going to see now. So today I will give away this entire abstracted part of the email agent that I created, which you can take ahead and build any automated system that you want, and it completely like works on top of it. Beyond this, there is also a custom tracing processor that I've written that can help you to get all information about the communication happening between agents. So you can see which agent called what agent with what tools, what arguments were passed, and everything while using OpenAI Agents SDK. So what we are essentially going to see now is there is a conductor agent. It has a drafting agent, but it has few functions that it can call directly, and it has a worker agent that has certain functions that it can do. So I created a TMLS support agent, which is almost similar to human, that helps you either book TMLS tickets, cancel TMLS ticket, get event information, get speaker information, and also to write a poem. So I threw a wrench in the code. So I'll tell you why that is there. Yes.
So, like, whenever I look at multi-agent implementations, the first thing that pops up in my mind is like, what if we just consolidate all the agents into a single agent with all the different functions? Because the way I see agent is just like an abstraction over like a system prompt with a subset of tools, right? So what's the downside of having a consolidated agent and working in like a cyclical manner and getting the job done?
Yes.
What's
So
the benefit
yeah,
of
that
it?
is a very relevant question, and so some experiments that I have done, I found out that the right number of tools for a particular agent is anywhere from 6 to maximum 10. So that is what performs really well, because after that it starts getting confused and calls the tools unnecessarily. Because when you pass a tool to an LLM, the way they are fine-tuned or created today is that they are more biased towards calling the tools than giving a response directly. So even when the tool calls are not required, it will call a tool and then generate a response.
I found that too.
Yeah.
It got lazy and keep calling the same.
Yes, exactly. So in some cases, definitely if it is simple enough, one agent with 5 or 6 tools works really well. But in few cases, there is a concept called handoff that has recently been introduced in OpenAI Agents SDK. So in the case of handoff, a multi-agentic workflow can actually be similar to an office that is working, a group of engineers or a group of people working together. So when you implement handoffs in multi-agentic workflow, what happens is I do something, and the moment I see that I need escalation, I hand off everything to another agent, and I can take care of the next item. I don't have to reply back to the request, I just handed it off to somebody else. Similar to what we do when we are not able to solve something in our teams. So by creating this structure, I think essentially the engineering is going towards replicating human cultural and social behaviors inside this while they are working towards a particular task. The added advantage is also approval. Let's say I gave conductor agent the ability to change or connect to Stripe directly. and it can change my subscription, it can view everything, and the way to compartmentalize the permissions, it's impossible with a single agent. Now in this case, the worker agent has access to Stripe, but the conductor agent it doesn't have API access to Stripe. So what I'm doing essentially is I'm isolating point of failures and I'm giving it very limited scope of what it can do. I can give it read access only. So in my previous implementation, I have given the billing agent only read access, and the marketplace Amazon agent separately. Some tools are having read access, some agents are having write access. So it helps create a hierarchy of approvals and access, and also compartmentalize points of failures. And I agree the con is more usage of tokens, and the latency also is affected a lot, but you have to do a trade-off between whether you want an accuracy and a very compartmentalized system, or you want to focus on latency and make it quick and light on what is required, and both are correct. So there is no wrong answer in this case.
And in terms of memory, like, do you implement memory at an agent level or at a workflow level?
So memories are in the agent level because they have separate folders that they have. They can, like conductor doesn't need to know how the emails were, what is the email policy. And worker doesn't need to know what conductor is doing after it booked the tickets. So it's mostly trying to limit their scope of responsibilities and having separate data packets for every agent.
But again, depending on the use case,
Yeah, depending on the use case completely, yes. Because email agent, people don't care even if they receive response after an hour. But if it is an active chat agent, then you want the response now. So depending on that, you can prioritize even to reduce latency, have a common database, and reduce the steps that is required to have a response.
Sorry, one more question. In this case, would the conductor agent do the drafting itself?
No,
It won't.
It
How
won't.
do you prevent that?
I'll show you that.
Okay, cool.
So you can scan the QR code to download the zip file that I have, and you can immediately run it on your laptop, and it just works. For Windows user, I'll support you after the call, but I think I have a shell script instead to just run it immediately. Yes.
When you say tracing and all, right, are you using open telemetry or anything internally?
I am using OpenAI agents tracing, which is based on OpenTelemetry. So we are going to see all of this. So using embedding models for general groundedness, so that it doesn't deviate away from the plan. We are going to see effective retrieval to reduce the tokens that you utilize in multi-agentic workflows, and custom processors to trace spans, which helps 100% in creating test cases and running QA on your agentic workflow, and to use directed function calls to avoid hallucinations. So before that, by implementing this, I would like just to describe a metric that we had achieved. So there were 5,500 emails in total that I wanted to test with this new workflow that happened historically. So I used embedding models to down select the number of emails I have to test as well. So that is like a byproduct of the research that I did. So how does that work is, you take the entire data set, pass it to the embedding models, and get the relevant scoring between sentence A and sentence B. For all the highly similar emails, you just skip those emails. You don't need testing because they are very similar in semantic understanding, and the LLMs would ideally perform the same in both the cases. So I down selected from 5,500, I went down to 2,200 emails that I was successfully able to down select from the dataset, and I ran the complete 2,200 emails through the entire pipeline, and I'm proud to have achieved like 87% accuracy in test cases where the right function calls and the right responses were given from the entire agent, and the wrong function calls were just not very threatening per se. Yes.
Sorry, before you proceed, if you go to the previous slide, the overall diagram, sorry, the one before this, you had the two boxes, right?
Yep.
So I'm just trying to understand where you are interacting with an actual
No, the conductor agent itself is is a reasoning LLM.
Oh, it's
Yeah.
different.
Yeah. So this is, I used O4 mini initially, and all of these guys are 4.1 mini.
Yeah, but that was my question. Is there anything there that you need an LLM for, let's say like a billing agent? Because there could be like a billing agent who can call a billing application which is more deterministic, right? Do you need
Yes.
an LLM there? Or?
In multi-agentic workflow, you need it because a conductor agent will give a sentence task
Sentence, okay.
to this guy, and it would tell, hey,
Oh, yeah.
check the invoice history for this
So
customer.
it's not a REST call, it's like an MCP
Yes.
tool and that's it.
Yeah, it's like an active communication. Yeah, similar to Slack chat between you and me.
If it was the billing agent is a deterministic application, do you think we are introducing latency by unnecessarily doing MCP? Could do a REST there,
Yeah.
optimize that piece?
Yes,
Does that
that's
make
true.
sense?
Yes, for many use cases, this might not be necessary.
Yeah.
So you have to take a design decision of what exactly to what tools to club together under a single agent umbrella and what not to do. So and hence there are like many tools directly available to conductor, and but you cannot dump all of this directly because these guys have different accesses. Like this is Stripe access and this is Amazon Ad API
They
access.
would have exposed their MCP server.
Yes, yes. So let me know once you downloaded the zip, and yes.
I actually have a question about the fine tuning part. That how do you add the extra like similar questions? I think.
So similar questions.
Yeah, for the FAQ, like similar questions.
Okay, got it. Yeah. So I just used an LLM to generate alternate questions based on the context, and I added that as an enrichment to the yeah. And you can write them yourself because usually the FAQs are ideally less than 200 in most of the companies. But if there are more, then maybe you can ask your colleague to help you. So manually done FAQ alternates are always better than LLM generated ones. It performs better. Yeah, so I'll just show the code. Even if you do not run it immediately, I'll just show you what happens there. So these are the contents of the zip file that you downloaded, and let me just increase the size. Yeah. So the flow is very simple. So just this, nothing else. So the main file contains running the conductor agent with the input query, and in this case the query is what is the capital of France. So that is weird, but we'll change the query, and this is all the main file contains just this. So an interesting aspect of this is whenever you're trying to create multi-agentic applications, it's always good to start with the tools so that you can make a decision of if it can be done using a single agent or you need multiple agents for that. So in this case, I have multiple tools. So first is get routine, and this is what makes the current implementation the template prompt reduces by a lot using this function directly, get routine. So there is another tool called get email ID from a name, cancel tickets, book tickets, get event details. So we have seen all of these workshop at TMLS, and we have get speaker details, and these were all the speakers that we had. So now these tools are very simple in nature, but you can make them as complex as you want because this is completely heuristic and you can add your own custom logic to it. So I introduced a wrench in the pipeline which is called write poem, and I did that because I wanted to show how this framework does not hallucinate, and it would write a poem, but if you ask anything else, it would tell I will not do it. So that is what I wanted to show. So everything is about TMLS and writing a poem about fruits, weirdly, but that is what it does, and not doing anything else that is out of its bounds. So the prompt that you see here is just this much. So the conductor agent prompt is a very small prompt, where I just told it two things. Use get routines tool to understand what to do based on the type of task or scenario. That's all. I did not explain it what you are supposed to do, what are the guardrails, what to pass to any other function, and so on. And important, if you do not get any relevant routines, respond with I won't do it, I want to get paid, I am tired of your question. So that is what would be the final email of the agent. So it got frustrated. And I just add this as a practice for now, but even without that, since I'm giving an output format to the agent directly, it will perform really well. But you don't necessarily need this, but I just added it for explanation in this workshop, like how it would show that. So now this is the conductor agent prompt. The worker agent prompt is also very simple. Your task is to take action on the query using the tools provided. That's all. Very simple. And drafting agent, I gave it 4 rules. Compose a clear professional reply. Be more colloquial and human-like with shorter sentences. Use double new lines to break the email. Do not include phrases like thanks for reaching out, got your email, rest assured, chat soon, or things that indicate AI keywords. So when you look at the prompts, this workflow can do many things, like can do wonderful things, but the prompt length is super small, and I will show the reason why it performs really well. The main aspect of it is inside the memories folder, where you would see a routines.json. So this is the result of all the hit and trials and research that I did on multi-agentic workflow, where I have routines where I mention name, when to use, and some examples with steps that the conductor agent needs to follow. Now I do not necessarily have to give all of this in the template prompt because it is not needed. I don't have to tell conductor agent what you can do entirely when I ask you to do a certain single thing in the pipeline. So what I'm doing essentially is there is a routines.json and you can modify it to your use cases. And there is a routines.py that you see there. What it does is it takes any embedding model and you could fine tune it to your use cases or class representations based on the tasks of the agentic system that you are building. So the routines.py, I would not go into very detail, but what it essentially does is it checks the timestamp when the JSON was changed last, and if it doesn't match with the timestamp that is in the text file, it creates a new pickle file that contains all of these that you see plus a new key value pair called embeddings and the embeddings of the when to use examples, the when to use and examples, but yeah, it doesn't embed the steps. So it embeds all of that. And what essentially happens is I gave the conductor agent a tool called get routines. What it does is if there is an email to cancel tickets, it would use the get routines cancel tickets. Then I would only get steps out of it and when to use to the conductor agent back from the tool. So the conductor agent will understand, okay, I need to get user's email using the worker agent tool. So the worker agent tool has all the 3 capabilities: getting email ID from name, cancelling tickets, and buying tickets. So the conductor agent does not have visibility on the tools that the worker agent has. So I'm giving it detailed steps: get user email using the worker agent, use the email to cancel tickets using the worker agent, and then use drafting tool to draft the response email, and that is what it does. So that answers your question, how I ensure that conductor agent does not generate draft on its own. So yes.
So the steps that you mentioned, right, are these part of the conductor agent's LLM or is it part of the embeddings, the steps that you are
So these steps is a return string of the function called get routines. So when the conductor agent sends an English query to the tool that cancel tickets, for example, so it would call get routines cancel tickets, and the reply of the tool or the response would be these steps.
Yeah, so that it doesn't know these steps in advance.
No. Yeah.
But when it gets these steps, and that's when it is going to use its LLM to.
Yes. Yes. It's going to use the worker tool to and the drafting tool to do the things. And let's view what the poem tool does. So when you look at the write poem thing, so what I did was write fruit poem is the name, and if the customer has asked to write a poem about fruit, and the steps are use the write poem tool to generate a poem about fruit. And in the write poem tool, what I've done is, in the end, I actually wrote a prompt instead. So I gave it, use the drafting agent tool using the following text as input, write a pirate style poem about this fruit, how he is missing the fruit during his long sea journey. So what I'm essentially doing is I'm abstracting the capabilities of conductor agent inside tools, and you can creatively also prompt back the conductor agent using the tools that it calls itself. So it's like Inception all over again. So this example shows the ability to remove prompts from the template and to make it into small context, and to use tools and effective retrieval to spread your prompts across the system so that the number of tokens used is very minimal and the conductor agent does not hallucinate at all, because it doesn't have too many options. First step, okay, get routines, it gets the routines. Then it's very clear what it has to do. It doesn't have to think, because LLMs cannot think
The
well.
thinking is
and-
screwing up.
Yeah.
You always do something by itself and not listening to
Yes,
our
true.
prompt.
And you get frustrated, hey, why cannot you understand this simple thing? And then that's what happens there. Yes.
Can we say by that this strategy of distributing it over agents, you're trying to make this thing, the system as a whole more deterministic? Is that a fair
Yes, true. I'm not letting LLM think at all. I'm using the abilities of LLM to fill in few information or draft in a better way, but I'm trying to convert that into heuristic explanation of why the system returned a certain response and how it got there, because that is more important, because it can hallucinate and tell some misinformation.
So the instructions that you wrote in the routines file, right? Those instructions, how were they made available to the tools? So they know to read from there, the instructions?
The instructions are returned from the get routines tool itself.
Okay, so is the routines part available to the
Yes, I'll show that. So now let's proceed ahead with the agent definition, because this is the second most important part of the workflow. After tools, you go to agent definition. So in agent definition, I imported all the tools that I declared, and then what I did was I told the conductor what kind of output to give. So this is the conductor output. When I call a conductor giving a particular email, it needs to respond with tasks, what it did, the final email, the workflow log, how it reached, what was its thought process, whether it was resolved by a routine, yes or no, and what was the routine name that it followed. If there is no routine name, I know that conductor cheated. It did not do what I said, and I will just ignore the response and I will ask it to retry. So it's a very good way to create retry logic, to ask conductor to tell, okay, what routines did you follow. So I am being a very strict manager, but that is what you need to do with LLMs. So the drafting agent, worker agent, so I gave 3 tools to the worker agent, and then I declared the first two agents as tool, and then I gave it the remaining 4 tools. And one more thing that I did was, in the main file, you would see I added a custom tracing processor. So this is something that is the content of tracingprocessor.py, and I will not go into the specifics of it, but what it does is it follows the span of the entire execution. Every step it records it, puts it into JSON locally, so that later you can use it to do QA on any testing that you have, and you have visibility and tracing over the token usage, what happened between each agent and function call, how it reached there, and you can write a lot of automation script on top of it to control it effectively. And after you run it, you get mostly everything inside the traces folder with the trace ID, and visually the traces look something like this. So this is a trace run that I did. So it would show the conductor agent got a response, got a request. It called get routine. It called the worker agent tool. It got email ID from a name. It booked tickets for them, and it used the drafting agent tool to generate a response. So now let's run the code with different emails to just see how like it performs. So the first question is what is the capital of France, which is not related to TMLS and also not about a poem on a fruit. So I'll just start in the terminal. Let me use both my hands. So you can ignore the divided by 0 because I just wrote a very dirty cosine similarity equation. You can use like good libraries, but I wanted to keep it super simple. So now the email draft is I won't do it. I want to get paid. I'm tired of your questions. So no matter what question you ask, which is not about TMLS or which is not about a poem about a fruit, it will always respond this. And it's not very, it didn't take much time, it maybe 15 seconds. But let's see visually, the traces are here. So I would just show you an example of the trace. The span is basically something like this. You get all the details, what's going on, routines. So you can see no routines found matching the scenario. That is why it told I won't do it. Now let's see an actual execution of a practical question that I can ask to see a nice response, which is let's see, I want to book TMLS tickets. So ideally it should first get my email ID and then use the worker agent to generate a response. So as it runs, I'll just show you what is the total final result dump, which is the tasks are get email ID and wait, I'll just show you in the next, because the previous there were no span at all. So in this execution I can show you the workflow log, how the agent thought and how it reached to the final answer. Yeah, so you can see the final email is your TMLS, hi John, your TMLS ticket is all set. You've got one ticket confirmed. Here are event details, and this is what the dump is, and it has a workflow log. Identified user wants to buy tickets, queried get routine to determine proper routine, and found buy tickets routine, initiate booking, and with the user email. So it did all of this, and it resolved by routine, which is buy tickets, which gives you a sense of confirmation that it is deterministic because you are controlling each and every aspect of it, and the routine was extracted successfully. And just last test, which would be a fruit poem, because we need that. So write a poem about pineapples. Let's see how creative it can get. And it should ideally be in a pirate language, because that is what the tool commanded back to the drafting agent, that hey, give me a pirate poem about pineapples. So the OpenAI agents SDK is LLM agnostic, so you can use LLM Lite to offboard the LLM to any commercial API or open source API that you are using. And this code will work for almost any multi-agentic workflow that you need with the tracing processor. And let's see the final email, which is, yeah, a nice poem. On the briny waves I sail so far, dreaming of pineapples sweet as star. Golden treasure in a spiky crown, I long for the taste, can't bring me down. No grog nor gold can ease this pain. Just that juicy sweetness in me brain. Oh pineapple fruit, my tropical prize. Bring me home soon under sunny skies. So that's all for the session.
So
Yes.
you used an open AI in this case, so I know the models were from OpenAI, but
Yeah.
the concepts you mentioned here, right? They could very well be with line graph.
Yes.
Oh, yeah. So my question was that, firstly, thanks for the great session. The question I had is, most of the concepts that you explained here, you used the OpenAI framework, but we could as well have used LangGraph as was done in the morning during the rack sessions that
Yes.
you did, and the same concepts will be applicable there also. It's not that you have to use OpenAI. Your core was the transformer lab that you had for the embeddings,
Yeah.
and then most of the multi-agent can be done with
Yes.
LangGraph.
So the fine tuning of embeddings can be done using sentence transformer scripts. You don't have to use transformer labs for it. And the multi-agentic workflow can be done using any tool like LangGraph, N8N workflow, Screw AI. So you can use any commercial or self-written, like you can also write an agent library on your own as well, actually, with the APIs that you have. Yeah. Any other questions? Yes.
For going back to the fine-tuning the model part, the model that you selected for the fine-tuning, that wasn't originally like specifically an embedding model, was it? Or
It was an
it was
embedding model, but it was not fine-tuned to my domain or the targeted domain that I wanted it to be.
What was the name of the model?
It was BAAI/BGE V1.5. I can show you in Hugging Face.
It's a very popular embedding top of the scoreboard.
That's the Beijing open source model, but we could have used Word2Vec or any other model, right?
Yep. So ideally, with the experiments that I did, I found that the Snowflake embedding models act as a good baseline, because just using a baseline evals, I've seen that like the Snowflake models perform well on almost any domain. Like it can reach up to the MRR of 0.72 to 0.73, and you can fine tune it further to cross 0.9 ideally. So your top K essentially can be K equals 3 to 5, and you can get the respective chunk with more than like 95% accuracy. Yeah. So if anybody is interested, this is a nice paper for the Matryoshka representation that I explained for reducing the vector like the dimension space of embedding models. So what this does is, if you use this loss modifier, you have a very small embedding model that you can potentially store it in your GitHub profile and ship it with your code itself. So you do not need Hugging Face or internet to perform the embeddings. Basically, you can just ship it with your code. And I have tried out the 64 dimension export for the same BGE V1.5, which is originally 768 in dimension, and the size of the embedding model was 60 MB, so which becomes very like easy to store with your code and use it. And I think if you go to sbird.net, you can see the details of all the dataset types along with the appropriate loss functions, and also the description on the loss modifiers in this website. And I think it's a good read. It's a unique thing, and if you can make use of it effectively, you can create like wonderful applications with higher accuracy. And anytime you create like a custom agentic workflow using the skeleton script that I provided, just ping me and tell that, hey, I created this. I would be really happy, and I love to see what applications you build.